In this video, we're going to have a look at how we can graph a trig function, more specifically the sine function that has undergone both amplitude and period dilation, as well as undergone some horizontal and vertical translations. So consider this example here, y equals 3 times sine 2 times t minus pi over 4 plus 2. We're going to graph this particular function here over a domain of pi over 4 and 5 pi over 4. So to do this, firstly recall the equation of something that's been a trig function that's been dilated and it's also been translated. So we've got a sine n t plus or minus epsilon plus b. And breaking down this particular form, we've got here the amplitude dilation, the period dilation, the horizontal translation, or x translation, and then we've got the vertical translation, b. So in the form that we've got over here, we're going to see that our a will equal 3. Our period dilation is going to be a factor of 2. The epsilon is going to be pi over 4, or negative pi over 4. And finally, our b, our vertical translation, is going to be positive 2. So to graph this particular function, firstly, what I'm going to do is I'm going to figure out the translation points, or where this function will start at, and then secondly I'm going to look at the period, see the length of a single cycle of this function, then I'm going to draw it, and then I'm going to extend it over the full domain, making sure I've graphed everything or removing the parts that I don't need. So to begin, what I'm going to do is I'm going to get my axes out, and we'll use this one here, and it's not quite right. Here we go. So I'll just draw some axes, and then I'll position it on my paper. Perfect. Now, second part is I need to figure out what the period's going to be. So recall period is equal to 2 pi divided by n. In this case, our n is going to be 2. Thus, our period for this function is pi. So what that means is, if I annotate this graph, so this will be on the t-axis, we'll call this our horizontal will be the t-axis, we'll say it starts at 0 radians, then we'll go to pi over 4 radians, then doubling that, we go to pi over 2 radians. Going a little bit further than that, we're going to go to, our next one will be 3 pi over 4. Going one across, we're going to go to pi. One across again, we're going to get 5 pi over 4. And one after that, we're going to get 6 pi over 4, or we can say 6 pi over 4, or we can go 3 pi over 2. Now notice that the start point is going to go, where is it, pi over 4, because it's our delta, or our epsilon, sorry, is negative pi over 4. It means we're going to start on the right hand side of the graph at pi over 4. So somewhere here. And that period itself, it's pi, so we have to count pi onwards. So there's a quarter, a half, 3/4, and a full. So the period of this function, or one complete cycle, is going to start at pi over 4 and finish at 5 pi over 4. Now we have to look at the vertical axis. So what we're going to say is that we've got an amplitude of 3, or a scaling factor, dilation of 3, and then we've got a translation of positive 2. So the graph itself, it's going to start at this point here, so where B is. So we could write epsilon or negative epsilon, and then b. This would be these coordinates here. So notice epsilon's already negative, so it becomes pi over 4. So this will be pi over 4, and then the b is going to be plus 2. So filling in those values, we're going to get pi over 4 and then positive 2. Then we have to go pi radians across. So here, this is going to be 5 pi over 4 and then 2. Now, filling out the rest of our vertical axis, we'll take it up to 5 because the maximum of this function is going to be the a plus the b, which is 3 plus 2, which will be 5. And then we're going to get a negative of negative 1, so it will be the a, 3, so it will be b, the 2, take away 3, which will be negative 1. So the behavior of this function here is it's going to start at pi over 4, 2, finish at 5 pi over 4, and 2 as well. But the maximum is going to be up here, and we'll go back to 0 at 3 pi over 4, then go down for a minimum at pi. Now graphing this function, doing the general shape of a sine wave. So I'm going to start at 0 here, or what would be 0, go up to the maximum, head downwards to the minimum, and then finishing it back up. Perfect. So this would be the general shape we would expect to see. So just cleaning it up. Beautiful. Now what I'm going to do is I'm going to check back and see, do I need to extend it left or to the right, or do I need to reduce it on the left or right based on the domain? And what we can see is our domain is between pi on 4 and 5 pi on 4 in this example. And notice that we're exactly within our domain here. So pi on 4 and finishing at 5 pi on 4. Now the next parts of information I could put on this graph is I could say the maximum, so this point here, this is at point pi over 2 and 3 plus 2, which is 5. The minimum down here, this is at pi radians, and it is at negative 1 on the y-axis, which I should have included there. And then finally this turning point here, or this point of inflection, this is going to be at 3 pi on 4. And it's also going to be at b, or 2. Now these points where we cross the x-axis, we could calculate them if we rearrange our equation up here. But the simplest way to do that is simply get your graphics calculator, and the graphics calculator will tell you the points at which your graph here cuts the axis. So if you're in an exam or in a test where you've got access to a calculator, don't calculate it here using rearranging this formula. Simply just look at the intercepts on your calculator, just saving yourself some time. But in summary, this is how we would graph a sine function that has undergone both period and amplitude dilation, as well as the vertical and horizontal translations, if we were sketching it using pen and paper.